How to calculate this definite integral out of ln x function? Actually, there is no way we can do it. It's unsolvable. And as usual, in Calculus 2, if we're in trouble in Calculus 2, what we're going to do? What's going to help, not always, but often, is integration by parts. So let's try to apply integration by parts. Let's bring the formula from the previous presentations. Okay? So the first step is to recognize u and v prime. So we need to assign who is who. ln x, is it v prime function or u or what? So let's recognize, or maybe guess. That is okay. Okay, so let's guess that that is our u function. ln x will be our u function, but what's v prime then? There is nothing here at all. What is v prime? Not a problem. Let's introduce 1 times 1. That's going to be our v prime. Okay, so then we can follow the blueprint, which is green in this case. I mean, to follow this formula, to follow this algorithm. So then we need to figure out all the ingredients. Some of them are given, like u is given and v prime is given. We still need v and u prime. Okay, so and then I'm gonna present a little bit different way of managing these integration by parts, a little bit different from the one you may see in the textbook and the videos, but it will be really helpful in the most complicated problems. For easier problems, you can use any of the method, but for really complicated ones, that's going to be the shortcut and really helpful way to resolve a complicated problem. So we're going to say we need to differentiate u. Why do we need to differentiate u? Because on the right side of the equation, we need u prime. And I'm also going to say we're going to integrate v prime. Okay, so once again, we need to differentiate u, right? So that's what I'm saying here. We are going to differentiate u because we need it here on the right side of the equation. And we're gonna integrate v prime because we need v on the right side of the equation. So we're gonna differentiate and we're gonna integrate. Differentiate this column and integrate this column. Let's do it. Let's differentiate first. What's u prime? What's the derivative of u? Derivative of ln? No problem. That's 1 over x. We cannot integrate ln x. We can easily differentiate ln function. Okay? So then let's integrate. We need to integrate v prime to get v function. It's nice to integrate 1. Let's integrate 1. What's integral of 1? It is x. Then what? Then go red. Then go diagonal. Then u times v, because we need it right here. That's our u, and that's our v, because we integrated v prime, and we've got v right here. So u times v minus integral u prime times v. Where's u prime? We differentiated u. U prime is here, and v is here. So that means we go light green. Okay? So let's apply the formula now. Let's apply the formula to the given unsolvable integral ln x dx. It's equal to u times v on the right side, u times v. Go red, u times v. U times v, ln x times x. That's the red step, okay? Minus integral out of u prime v. This is our u prime. We differentiated u in this column. And this is our v. We integrated v prime in this column. So minus u prime v. We go green, light green. That's the next step. Integral u prime times v. U prime times v. Okay. So it looks actually nice. Let's simplify. 1 over x times x. Let's simplify the whole expression, the whole function on the right side. So we have x times ln minus integral out of dx, or integral out of 1 times dx. We can do it. Let's integrate this one. So it's just x. It's equal to x. Now, we're not done yet because we were given originally definite integral with the limits of integration from 3 to 5. From 3 to 5. So we need to apply limits of integration to the answer we've got so far. Okay? And then we plug in the upper limit of integration, plug in instead of x, plug in upper limit of integration, minus plug in lower limit of integration into the same expression. Okay, now we're done. Well, we can simplify this algebraically a little bit to get final answer. And the final answer will be 5 ln 5 minus 3 ln 3 minus 5 plus 3. So that's the final answer for the given problem. That was unsolvable integral, but we were able to evaluate this integral, definite integral, using integration by parts method.